So now that we know how to make and use variables, how to compare them, and what we can do with those comparisons, let's move on to another foundational concept of computer science, and that is arrays. Now we've already talked about variables, and how great they are for storing singular bits of information for making our code more simplistic. But one of the biggest drawbacks that comes with variables is their inability to hold more than one piece of differing information. For example, let's say you're making an app which allows a user to create a grocery list. Well, there's no real easy way to create lists using variables, because it's not like you can have one variable store the names of 6 or 7 different food items. Remember, we can only put one piece of paper in our cardboard box, no more. And besides, even if you were able to add multiple items to one string variable, you would still have a lot of trouble doing simple tasks you might want from a list, such as searching through it, splitting it, or even deleting items from the list when you're done with them. This is the problem that using arrays solves for us. An array is, as you may have guessed by now, a list. You can have an array of integers, an array of strings, and even an array of other arrays, which is something we'll cover in a minute. Programmers use arrays when they want to store a lot of variables containing information that is all related to each other, such as a grocery list or a high score list in a game. Think of arrays as a column in Excel or Google Sheets. You have the title at the top, and then below it are a bunch of bits of information which all relate back to the title. Arrays are super useful when programmers want to store a lot of information that can be easily searched through, because programmers have developed methods of breaking down and using arrays to find specific information in arrays full of thousands of different variables. As an example to show just how useful arrays are, let's say you're a startup company that owns an app that has 100,000 users. Every time a user wants to create a new account, they input the username they want, and then your program will have to check to make sure the account name hasn't already been taken. Doing this requires you to search through the information of all 100,000 of your users to see if that username has an account with your service. An array would be able to contain all of this information and make it easy to search through and find out if the account name has already been taken, with little to no delay. Now, the single most important thing to note about arrays is how you reference each element of the array within them. Let's create a basic array called numbers, and inside of it put the digits 1 through 10. Now, when we want to refer to each cell in this array, we would call upon its index. An index is just a fancy way of saying that number's place within the array. Now, you would think that the first integer in this array would be the first index, the second would be the second index, and so on, but that's simply not the case. In computer science, programming languages refer to the first cell as the 0th element in the array. This means that if we were talking about our array of numbers we just made, the number 4 would actually be in the third index, 5 would be in the fourth, and so on. So instead of starting our count from 1, we start from 0. It's extremely weird and confusing, but it's one of those programming quirks you're going to have to memorize and commit to memory. If you were to not follow this nomenclature and refer to the last element in this array as the 10th, you get what is referred to as an array out of bounds error, since you're trying to reference the 10th element, but there is no 10th element. What you're actually trying to do is reference the 9th element. Another extremely important thing to note about arrays has to do with their size. When you initialize an array, you can do it in either one of two ways. You can either populate it with the elements that you want contained in the array right then and there, creating and filling the array at the same time, or you can define how many elements you want the array to hold, essentially the array's size, and then populate it with elements later. This is because when we initialize an array, it creates a space in memory that has the size of exactly what you give it, no more and no less. This is great for when we want to access elements in the array because we can do so instantaneously because the computer knows exactly where in memory the array is stored. But the one downside is that we can't increase the size of the array later on. All array sizes are final. Think of this like setting up a bookshelf with books. By populating a bookshelf with a certain number of books, and then moving on and filling the next shelf with different books, we have no way to go back and add books to that first shelf without shifting everything over. Once we decide how much space to dedicate for an array in this case, there's no way to add more space. Once again, because this is extremely important to remember, this means that once an array has been defined, there is no way to change the size of it. If you have an array titled names with a size of 8, and you try to add another name to the array, you will receive an error. So be careful when messing around with array sizes. Of course, you can always go back to the start of your code when you initially make the array and allocate more space to it, increasing its size, if you find out that you need more space to hold items. but once it's defined, you cannot change its size through conventional methods. Another small thing I want to touch upon really quickly is that when you initialize an array, you must determine which type of array it is right then and there. For example, you have to specifically say it will be an array of strings or integers when defining it, and also you're not allowed to mix and match, meaning that you can't have an array full of integers with a few strings and some doubles thrown into the mix. They all have to be the same type. Now the last thing we're going to cover on arrays is a little funky, and that is the practice of putting arrays inside of arrays. If you make an array of arrays, it is referred to as a 2D or two-dimensional array. Think of these as matrices if you have taken an algebra class before. Now if you haven't, think back to our Google Sheets example, but instead of using columns, we would add rows as well. So now each element in an array wouldn't simply just be a string variable or an integer variable, but an entirely new array with its own set of values and elements. The way we index these is mostly the same, except we would have two numbers to index instead of one. We start with the row and then the column. So a number in the position 0, 2 would be in the first row 3 columns down. In this case, the name Clint. A number in the position 1, 1 would be 2 rows down and 2 columns across. In this case, the name Chris. You get the idea. Now you can also make three-dimensional arrays by putting an array inside of an array inside of an array, but that's a little above what we're going to be covering, so I'm going to cut it off there.